just have them enter.
Okay, so yeah.
So they can hear me, right?
I hope so. So can you hear us over the YouTube stream? Do you have the YouTube stream open?
Didn't you put it on mute?
Well, that's not on mute. We can hear them. We can hear them talking on the phone. It's just that now there's the YouTube Live is streaming, but
nobody's answering. Anybody out there?
No, they can't hear you until you turn the mute off.
Oh.
Okay, I have the YouTube video streaming. Can anybody see it?
It's a funny voice.
I can.
Okay, I'm going to ask that you turn off you go on mute if you're not talking. Okay, I don't know if that was feedback from this through that.
I don't know. That's the problem.
Okay, can you hear me talking now? Why don't you... Yeah, go ahead, stand over there.
Okay.
We just need to establish that you can see and hear Dr. Mirabile.
Okay, I have to move this.
Okay.
Oh, we're not using this, right?
No, we're not using the Chromebook.
Good. So I can put this right on top of here. And that gives me some room to sit and to move here.
Okay, anybody on the call, can you see and hear Dr. Mirabile?
Right now I'm bending over.
Okay, I heard a yes, so I think we're live.
Okay. How many people are on?
I heard it yes, so I think we're live.
Can you guys see me now? I'm waving. Can you see the wave? If me and Greg go wave together, we can do a wave. Okay, well, I'm going to assume that people are on this and are hearing me.
Me and Greg wave together, we can do a wave.
Okay, we're getting feedback is the problem.
I'm talking to myself, I think.
Why is that happening?
I don't know.
We have that muted. The phone cannot pick us up.
Right. So who's picking us up?
I think the problem is that at least one student is not on mute, and they're getting...
All right, unless you're talking, you're about to talk, you should all be on mute. Otherwise, we get feedback here, and it's like an echo. Should we have a spokesman for the class?
A spokesman for the class?
To answer my questions related to administration. So not everybody's trying to answer my question.
Well, I mean, if they have a question, they can just...
No, I mean, like I'm asking, can you hear me now? If everybody tries to answer when you get the feedback.
Oh, I see. If we just pick somebody and say, hey, you're the tester. Well, they said that they can hear you. So if there's any problem, I guess we assume that they can hear. Can everybody still hear? Can somebody say, yes, I can hear you?
Yes, I can hear you.
Okay.
Okay, thanks.
Okay,
there might be a little bit of a delay, a few seconds, but I think that's manageable. So I think we're a go.
Okay, everybody. First of all, I have to say you're the best class that I almost never saw. I mean, this has really been, you think it's weird for you? It's been weird for me. I'm way outside of my comfort zone. We've tried the best we could. Some of the experiments worked, some of them didn't. But most schools that have online classes have taken years to develop them, and then to get rid of the bugs. Here we're trying to build an online program in a couple of weeks. So I apologize for anything that might not have seemed seamless, but we're learning just as well as you are. So today, this is our final exam review. And one at a time, I want to know, I have written the final exam for about 2 hours and 20 minutes, and I'm going to give you 3 hours and more if you need it. How many people would have a conflict if it went over 3 hours or over 2 hours? If you have, don't answer me now. Email me as soon as this review class is over, and we'll figure out something. Okay, so the final exams are going to be scheduled by me to go for 3 hours. That gives you a chance to complete the exam without rushing. If you're going to have a problem where you have a conflict with another exam after 2 hours, please email me after this review class, and we'll solve the problem. Okay. All right, so I'm going to go over problems from the final exam review sheet, which are problems like the final. Final is already made up. It's will be put in your docs before the final exam date. So if you go to your review questions, I'm going to do number 2. And we have C of x equals 19 minus 10. It's the square root of 4x squared minus 9. Rewriting this, 4x squared minus 9 to the 1/2. It says here, if the total cost of product X is $20, find the number of units needed to meet this $20 cost. All right. So what I just want you to do is go C20 equals 19 minus 10, 4 times 20 squared minus 4 to the 1/2. I'm going to leave that like that. Try not to block the board. That's a simple substitution. Not worried about that. B says find the marginal cost. You got to take the derivative. We have 2 terms here, so we have to do the derivative with respect to both terms. All right, this is going to be 0. This is your chain rule. What is the chain rule? Chain rule for differentiation. If I'm given y equals, we can have here a u to the n, and we know that dy dx is going to equal to na u n plus 1. I'm sorry, n minus 1, who we're doing differentiation here, times du dx. All right, so we have to, in this problem, n equals 10. I'm sorry, a equals 10. This is a equals 10. N is 1/2. We're going to look at u equal to 4x squared minus 4. What's inside the argument here? It's raised to the power. And du dx is 8x. Substituting into the rule here, dy dx equals n, which is 1/2. A, which is 10. U, which is 4x squared, minus 4, to the n minus 1, 1/2 minus 1, times du dx, which is 8x. This comes out to be 5. 4x squared minus 4. This is 1/2 minus 1. It's going to be minus 1/2 times 8x. So what is your answer here? First term is 0. So dy dx, the whole function dcx, is going to be 0 plus 40x, 4x squared minus 4 to the minus 1/2. And that's your answer.
Anything you can do to write it a little bigger would be
Write it a little bit bigger. Okay, I'll try. And it says find the marginal cost when x is 10 units. So now that we have this is c prime of x. Let me erase this. Sorry, but I'm going to have to do a lot of erasing. That's the problem with doing these. Ward space was a premium here. So c prime at 10 is equal to 40 times 10, 4 times 10 squared, minus 4 to the 1/2. $400. 400 minus 4, 396. The square root of that. Would you get me my calculator there? I didn't. I don't have my answers right behind me.
Mirabile.
Yes. Question?
Isn't it negative 40 though, because it's negative 10?
Yeah, right. Sorry. Was the first one negative? Yes, it was. I'm sorry. Yeah, it's minus. But this is still the square root. So the answer is going to be minus. Thank you. You can't even find it. Can you find my? Oh, here it is. Oh, my buttons have faded so much. I have to get a new calculator. That's 19.8. And I'll have you calculate the rest. I think I might stop over here from now on and have you do the calculation as long as you have the methodology just to save some time. That's going to be your answer. And the next question on that was find all critical points. So part C, for your critical points, you set the derivative equals 0. So you would have minus, it's going to be a minus 40x, 4x squared minus 4 to the 1/2 equals 0. So I would rewrite this like this, minus 40x over 4x squared minus 4 to the 1/2 equals 0. Now you can multiply both sides by 4x squared minus 4 to the 1/2. Notice this remains 0. This cancels and you have minus 40x equals 0. So your answer is 0. That means at 0, you do something. It says, now does this represent a maximum point or a minimum point? Well, how would you test that? Well, you can do your first derivative line test. I wouldn't suggest doing a second derivative here. It'll take you a lot of time. So let's do our first derivative line test here. And we're testing 0. So we'll go to -1 and 1. And what we want to find is the cost at 1. Well, let's do -1 so I know where I am. And the marginal cost at -1 and 1. This is going to be -40 minus 1. 4 times -1 squared minus 4, 1/2 equals 0. Now you see one of the problems with choosing -1 here is I'm going to get a 0 here. So this is going to be 4 minus 4. So this tells me I can't test that point. There could be an inflection point there. There could be something that I don't like. So I'm going to use -2 instead. Doesn't make any difference. It is on the left side. That's going to give me 8 times 16 minus 4, which is 12 to the 1/2. Now you know that's going to be positive, so you don't have to carry that out. That's going to be greater than 0. Let's try 1 here. -4 times 1. And what happens? The same thing happens. You get a 0. This tells me that I cannot do 1 and -1. If we would plot these things, we might find that we were dealing with some asymptotes, which I didn't ask you to find. So I'm going to try 2. I'm changing this to +2. That's going to be -8. It's going to be 12 to the 1/2. But no matter what this is going to be a minus. That's going to be less than 0. So I'm going to get -2 is plus, plus, plus. So this tells me that at x0, I maximize cost. Well, you don't want that, but that's what you have. So in this case, because there are asymptotes, most likely, or horizontal inflection points, which you don't have to worry about, this comes out. If you get something that comes out this way, don't worry about it. I'll assure you there's nothing like this on the test. Everything comes out pretty good on the test. I made sure I've checked and double checked. You shouldn't have anything where you have to worry about -1 and 1. Okay, let's look at the next one. As I flip the pages, I'm going to go to number 7 on your review sheet. Once again, these look like what's on the final, but I have cleaned them up so that they come out very well. So number 7, C of x equals 18,250 plus 615 natural log of 4x plus 10. It says here, find the marginal cost of producing 100 radios. Well, it wants us to find the derivative. Well, that is the derivative of 18,250 plus the derivative all right. This is 0. And I want you to notice one thing. This is not implicit differentiation because we're taking the derivative with respect to x, and we have an x in the function, we're taking the derivative. As long as these match, you can use your derivative rules. So what's your derivative rules here? So what's the log rules for derivatives that I gave you? And these will be on the back sheet of your final exam, so you don't have to worry about it. But the rule for logs is, if you're given y equals a log, natural log of u, we're only doing natural logs, then dy dx is going to be a over u times du dx. So what do we have here? In our problem here, we have a equals 615, u equals 4x plus 1, and du dx is 4. So dy dx comes out 615 over 4. 615 over u, I'm sorry, 4x plus 1.
4x plus 10. 615 over u. I'm sorry. 4x plus 10.
Okay, that's 4x plus 10. I can't hear him. What's the problem? Hello? What did he say?
It sounded like we had feedback and then somebody dropped.
Oh. Well, let's see. So far, everything's okay. This is the rule for logs. The rule for natural logs. It's a over u, which is 615 over 4x plus 10, and du dx would be 4. Okay, so it's 4 times 15, which is 6 and 24 over 4x plus 10. Oh, if my math is right, 2, 6, 24. That's the answer. Very simple. The log rule is simply take the u and put the coefficient over it. Multiply times du dx, which is just 4, and that's your answer. There is a log rule problem on the exam. Okay, let's go on to the next one. And the next one that I'm going to be doing is number 9 on your review. And number 9 says the income from an established chain of laundromats is a continuous stream with an annual flow rate. So this should be I prime t. The prime is missing. This is the I dt. And that equals 23,000. Somebody just to 230,000. E to the 0.03 t. Now we are given here the derivative, so we want to step back to find the income stream. But it says find the present value. I mean, anytime I'm giving the derivative and I find a present value or an income stream, I have to do an integration. So let's see what we have here. It says find the present value and it has to give us some conditions. For 8 years, the next 8 years, the interest rate is 7%. So what we have to use is the present value formulas. All these formulas will be given to you. The present value equals the integral, in this going from 0 to 8, I prime t e to the minus RT dt. And what is R? R is the interest percentage divided by 100. That's 7 over 100. And that's 0.07. I prime t is given over here. So we put that in here. Our present value for 8 years is 230,000 e 0.03t times e to the minus RT, e to the minus 0.07t dt. That's a plus, that's a minus. You add exponents. It's going to be e to the minus 0.04t dt. Okay, this is an exponential integration rule. And I'm going to write that down here. If I block the board a little bit, because I'm writing down a rule, but I will unblock the board very quickly. So our exponential integration rule says given the integral of dy equals the integral of a e to the u f of x dx, and y is going to be equal to a e to the u f of x over du dx. And in this case, you're taking it between 0 and 8. There's no constant because this is a definite integral. Once you have an integral that has these constants here, the bottom and top, you don't need a constant. So let's apply it to this one. Here we have a equals 230,000. U is going to be equal to minus 0.04t. U is always in the exponential. What's in the power? So du dt is minus 0.04. And where's f of x? Well, here f of x is 1. If there's not an appendage here in terms of x, or appendage here, it's 1. So f of x equals 1. So now let's solve. Y equals a, 230,000, e to the minus 0.04t. F of x is 1 divided by du dx, in this case is du dt, is minus 0.04. So what I have to do is divide the 0.04 into, divide 230,000 by 0.04. Minus 0.04, right? That's going to be 5 million. It's a high number. I've tried not to put any real high numbers on the final. There's a minus in front of there. Don't forget this is between 0 and 8. This is between 0 and 8. Now the easiest way to solve this is to take the constant, factor the constant out. And what does this say to do? Well, this says take the top one first. Where you see T, put an 8. Subtract that from the same value. But instead, where you see T, you put a 0.
Minus of it.
What?
Minus on the first exponent.
There is a minus over there.
The exponent.
Yes, I know. Just give me a break. I'm going to do it. I'm trying to get this board from stop shaking. A lot easier when I had 3 boards. Okay, so this is going to be e to the minus 0.32, 8 times 4, minus e to the 0. All right, I'm going to let you solve the rest of this. I'm not going to finish it. Put e to the minus 0.32. E to the 0, you know, is equal to 1. So you're going to get a negative here times a negative here. So you will come up with a positive y value because it's an income stream. If you do a problem like that and you come up with a negative value at the end, you know you did something wrong. Go back and check. When we're talking about present value or future value, you can never have a negative value, not for things that we're dealing with. Okay, well, this will be a positive value. If it's not, go back and check. Don't let it ride. All right. Let's go and do another one. All of these are very similar to what's on the final, as I said, but I'm not using those big numbers there. Okay. The next one we're going to deal with is number 10. Number 10 says on page 4, in an effort to make the distribution of income more nearly equal, the government of a socialist country passes a tax law in January 2010 to take effect immediately that changes the country's Lorentz function. Taxes, decrease or increase, will change the Lorentz function. Okay. So the old Lorentz function was 0.998 at 2.6 in the year 2005. After the tax legislation, it changes to 0.57x squared, and that should be a plus 43x. A plus is missing there. Okay, so we have the old y before the tax. The old Lorentz function is 0.998 x raised to the 2.6. That's year 2005. After tax, y equals 0.57x squared. I'm sorry, that's raised to the, sorry, my fault, that's 0.57x raised to the 2.43x. And this is 2010. There's no positive there. I forgot to put the parentheses in front of the 2.43x. Okay, so when they ask for distribution, they want the Gini coefficients. And the Gini coefficients are given by this formula, which will be given to you. I'm not going to leave you out the formulas. Now, these y's are your L of x's. So this is your L of x in 2005. This is your L of x in 2010. So you got to do 2 calculations here. I'm going to set it up for you. Not going to solve it. I don't want to be pressed for time here. So you're looking at the G in 2005. And this goes from 0 to 1. Okay, the way they've set it up, that's always a 0 to 1. That never changes. So G of old equals 2 0 to 1, x minus Lx, which is 0.998, x 2.6 dx. So here you cannot subtract this. So this is going to be 2, the integral 0 to 1, x dx minus 0 to 1, 0.998 x to the 2.6. Well, this is going to be 2 x 1 plus 1 using the standard formula for the power rule minus 0.998. And we have x to the 2.6. Same rule. X 2.6 plus 1 over 2.6 plus 1. And both of these are going from 0 to 8. All right?
0 to 1, I think.
0 to 1. I'm sorry, I'm back at the other problem. It's always 0 to 1 in Gini coefficients. I was back doing the present value.
Just dx.
All right, I'm going to leave it that way. I'll show you what to do. Well, let's do this. This is going to be 2x squared over 2 between 0 and 1 minus 0.958 divided by 3.6 x to the 3.6 power. Between 0 and 1. I'll set it up, but I'm not going to calculate it. So G in 2005 equals x squared 0, 1 minus.
I think that started at 998 and then developed into a 958 accidentally.
No, that's just no. I wrote it. It just looks like it. Yeah, I know. Unfortunately, my 9s and 5s. All right, you want to do the calculation? 0.998 over 3.6. That'll help me. And that'll be minus 0.998 over 3.6. Don't like it? Yeah, give me.
a lot of the functions are the keys are worn off, and I can't find the division.
Okay. 0.277. So it's going to be minus 0.277 x to the 3.6 x raised to the 3.6, right?
Yeah. I have my iPhone out ready to go if you need anything else.
Okay, thank you. Yeah, so this is going to be 1 squared minus 0 squared minus, keep this outside, 1 raised to the 3.6 minus 1 raised to the 0. What's 1 raised to the 3.6? Any 1 raised to any power is 1, right?
I don't even need the iPhone for that.
Okay. So this is going to be, I'll do this one out and then just set up the other one. So this is going to be 1 minus 0.2770. So this is 1. Okay, what's perfect? Perfect is 0. 0 means perfect distribution. This is pretty large. So that's why they did the next one to look at their taxes. Almost in between. That would have been long gone. All right, so we're going to do G at 2010 is the integral 0, 1 x minus the Lorentz function in 2010, which is 0.57 x to the 2.43 x, correct? That's what it says. Dx. So once again, you get 0, 1 x dx minus 0.51 x 2.43 x dx. 0.5, that 0.51 or 0.57. 0.57, my 1s and 7s. All right, the first one's pretty easy. Once again, it's x 1 plus 1 over 1 plus 1 minus 0.57. How do we do this one? This is an exponential, right? This has to be a chain rule, correct? So let's figure out how we use the chain rule on this. Well, let's do the second term here. Remember the first g was 1. So the second term here, this term here, we'll call that a. Let's work on that. And then we'll put it back in here. So how do we work on 1? Well, we're given that, let's say dy, whatever it is the integral of 0.57 x to the 2.43 x dx. Well, this is our integration chain rule. What is that? Our integration chain rule for polynomials says that if I'm given the integral of dy equals a u to the n f of x dx, then y is going to equal to a u to the n plus 1 over n plus 1 f of x dx. Now, you're going to run into a problem here. Let me show you what happens. What do we do here? Well, we know that a is 0.57, u is 2.3x, and du dx is 2.43. What's f of x? Well, f of x is 1. So let's see what we have here. This says y equals a u to the n. Well, what is n in this case? N equals 2.43x. Okay, this says 2.43x plus 1 over 2.43x plus 1 times f of x, which is 1, over 2.43, plus a constant. Well, how do you deal with this? Any way you want to, actually. It's going to be 0.57 over 2.43x plus 1 over u, which is, what would u? Is x to the u, which is 2.43x. 1 over 2.43 plus c. All right. The problem in this case is that you've never really gotten rid of the X. So it's not really a legal case, but I would take this answer. I believe when they developed this problem, they didn't want an X in there. All right. So you will not get a problem like this. This is basically a problem that cannot really be solved for a unique number unless we know some other stuff. So here we're just going to leave it this way. I cannot directly compare because I don't know what X is. I believe when they made this problem up, there should have been no X in there. If you want to try to solve it without the X, you will get a value. I'm not too worried about it because my problem on the exam does not have this problem. The real way you would integrate this is by integration by parts. Yes. Okay, so this was on a final 2 years ago. 3 years ago when I wasn't teaching this. And somehow it got on my review sheet because I copied the review sheet from another faculty years ago and never actually did this problem. My fault. But anyway, you won't get anything like that. Everything will come out very well. All right, let's go to number 11. This you have to know. The Gini coefficient is done just like I did before. Use the same formula. Part 1 of that in 2005 is what you would need. All right, let's say we're given this. And I know you have problems with this. 2p squared times q minus 9,000 p squared minus 10,000 equals 0. Let's check it. 2p raised to 2q. All right. And they give you p equals 50. All right. And they say find the elasticity of demand. So the elasticity of demand is given minus p over q dq dp. So I need p, I need q, and I need dq dp. P is 50. Step 1, find q. Find q from equation 1. Go back to equation 1 and substitute in what p is equal to. P is equal to 10. P is equal to 50, sorry. So p equals 50. This is going to be 50 squared. Q minus 9,000 50 squared minus 10,000 equals 0. It's going to be a very high number. This is going to be 2,500 times 2 is going to be 5,000 Q minus, so what's 2,500 times 9,000? 50 squared times 9,000. Oh, you're not going to do it?
Oh, sorry. I switched apps.
Oh. Jeez.
What is it? 9,000 times.
And it's 2, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 22 million. Minus 10,000 equals 0. So you're going to get 5,000 Q equals, bring everything over to the other side, 22,000, 500,000 minus 10,000 is 224,000,090, 22,490,000. So Q is 22,490,000 over 5,000. So it's 22,490 divided by 5. 4498. So Q is a high number. So we put that over here. We say P equals 50. Q equals 4498. And now we have to find dQ dP. We have 4498. Let's go back to the original function. Okay, I got to find what? I have to find dQ dP. And then I have everything for my elasticity function. Let's go back to here. I'm going to do ddP of 2p squared q minus ddP of 9,000 p squared minus ddP of 10,000, which is 0, equals 0. That's out. This is a product rule. U equals 2p squared. D equals Q. So ddP is going to be 2p squared. ddP of Q plus Q. ddP of P squared minus ddP of 9,000 p squared. This is minus 0 equals 0. Now notice you have PP here. I can do that directly using the normal power rule. I've got PP here. I can do that directly. So this is going to be Q times 2P. The derivative of P squared with respect to P is 2P. This is going to be ddP P squared. It's going to be minus 18,000 P equals 0. This one I can't do directly. This one I have a Q and a P. I have to make it with respect to P and then put an attachment on. So ddQ, Q, and to balance it, because I have a dQ in the denominator, I have to put a dQ in the numerator and balance it with a dP. What we get here is 2p squared. dQ is on 1. dQ dP plus 2pq minus 18,000p equals 0. My purpose was to find dQ dP. It's now a variable. What I'm going to do is bring everything not in dQ dP over to the other side. This is going to be minus 2pq plus 18,000. I'll write that again up here. So what we're left with is 2p squared dP dQ equals minus 2pq plus 18,000p. So now you want to free the dP dQ from 2p, so you divide both sides by 2p squared. So this is dQ dP. Yes?
I think that's the sound of somebody either entering or leaving the call.
Oh, okay. So this is going to be dQ dP equals minus 2PQ plus 18,000 P. What's the matter?
It's just hard to see on the
I'm sorry. 2P squared. Writing bigger is hard when the whole equation takes up the board. Okay. So now I have the equation for dq dt, but I don't have a value for it, which is what I need. So I'm going to substitute q equals 50, q equals 4498, and p equals 50. And I'm going to need your help in calculating this here. Do you have your app out?
Ready.
Good. That's 2p squared. So what do we got on top? 100 times 4498 is what?
4498 and a couple of zeros.
How many zeros?
A couple. It's 100. 449800. Forgot the 8. 4498. 00 for the 100.
That's because I haven't eaten yet.
And then
What's 50 times?
Is that 1800?
18,000.
18,000 times 50. Well, it's going to be 900,000.
And 2,500 times 2 is 5,000, right?
Yeah.
So subtract that. It looks like you get
449800 equals divide by 5,000 equals 90.04.
It's okay. So let's just say 90. So now I have everything. I have dq dp. And I want to find my Gini coefficient. Which is n is minus p over q times dq dp. It's going to be minus 50 over 4498 times 90. Looks like we're going to get a positive here. I'm sorry, a negative. That's going to be it's going to be 1 point something, right?
It's like 1, just pretty much exactly 1.
Yeah, almost 1. Let's say 1.01.
Yeah, because 50 times 90 is 4,500.
Yeah, I know. I know. Okay, is this greater than 1 or less than 1? That's minus 1. It's less than 1. So this is inelastic. Once you get a negative sign, it always has to be less than 1. Negatives on the left side of the number line. Okay, now, warning. dq dp is not your elasticity constant. I got that on a lot of my exams. No. It's this over here. You will be given this equation. You cannot get the elasticity constant without using p, q, and dq dp. I'm 100% sure that there's going to be one of these on the exam. In fact, I'm looking at it right now. Make sure you know how to do implicit differentiation. Okay, we're going to move on. And I'm going to do one which is always on the exam. Numbers are changed to protect the guilty. And I assure you, everyone I've done here is on the exam, except the one where we couldn't integrate. I would not do that to you. So 14 says, given. I'm sorry, that's 14. Yeah, it's 14 on your review sheet. I have changed this around. So this is revised. So it's not the same as it is in your review sheet. I revised it to look more like what I gave on the final. the marginal cost is going to be 50 over x squared plus 20. The marginal revenue, I've altered it to be 50 plus 10 over x squared. Also, given what they gave before, when the cost is, I believe, when the cost of 10 units is $600. So we want to find the total cost function. Well, since I'm given, this is the derivative. That's what marginal cost means. This is the derivative of the revenue. I have to integrate. So I'm going to say dc dx equals 50 over x squared plus 20. I'm going to revise this. 50 minus 2 plus 20, bringing it to the top. So dc equals 50x to the minus 2 plus 20 dx. So the integral of dc is going to be the integral of 50x to the minus 2 dx plus the integral of 20 dx. So we just used the power rule here. It's 50 x minus 2 plus 1 minus 2 plus 1 plus 20x. And since there are no limits on here between the top and the bottom of this is an indefinite integral, I have to find the constant. I cannot calculate a profit function without finding the constant. So let's find the constant, but let's clean this up a little bit. I'm going to write this on the side here. MR equals 50 plus 10 over x squared. It gives me some space here. Okay. So I'm given C10 equals 600. So let's take my value for CX, which when I clean it up is going to be minus 50 x to the minus 1 plus 20x plus c. I can write this minus 50 over x plus 20x plus c of x. Now I want to find my constant. It tells me when c is 10, when x is 10, c is 600. So substituting 10 for here, I know that's going to give me a value of 600. And then I'm going to substitute 10 over here. Plus 20 times 10 plus c. So what we get here is 600 equals minus 50 over 10.
Oh, wait, was it supposed to be there?
Oh, I dropped it. I don't have your room. Bend down.
Sorry.
Yeah, it's 50 over x. So x is 10, right?
Yeah, right, yeah. There was something from a previous problem, a smudge that looked exactly like an X right there.
Okay. This is minus 5. This is plus 200 plus c. So 600 is plus 195 plus c. Subtract 195 from both sides. Well, 200 would be 400, so c is 405. So now I have to give my complete cost function. So my complete cost function is going to be minus 50 over x plus 20x plus 405. There's my cost function. That answers part A. Part B says, find the constant, which I did. And it says, find the total revenue function. That's the next step. So let's look at my marginal revenue. Sorry, I have to keep erasing, but that's the nature of this. My marginal revenue is dr dx equals 50 plus 10 over x squared. Question?
I think that's the sound of somebody either entering or leaving.
Oh, okay. Okay. I'm going to rewrite this as 50 plus 10 x to the minus 2. So this is going to be another integration. With our squiggles. R of x is going to equal to, once again, 50x plus 10, x to the minus 2 plus 1, minus 2 plus 1 plus c. All right, so R of x is 50x plus minus 10, x to the minus 1 plus c. Or to look like the other one, 50x minus 10 over x plus c. And for revenue, I always assume that when x is 0, r is 0. So when r is 0, when x is 0, r is 0, there's going to be 50x, 50 times 0, minus 10. I really can't divide by 0, which is a problem in this problem. So we'll just have to assume in this problem, which I think I give it to you, assume that c is 0. Dividing by 0 doesn't really fit here. You get an infinite constant. But what we're going to do is say here, assume c equals 0. Let's make it a little bit easier. I just revised this before. So Rx is going to be 50x minus 10 over x. Now I have to find the profit function. The profit function is going to be R of x minus C of x. By the way, in real life, if we had gotten a division by 0, we would have to check our equations. Okay, we would have to go back and check whether the marginal equations were correct. In this case, we're not going to worry about it. You're not going to get something like this on your exam anyway. Whatever you get is going to be clear cut. So R of x is 50x minus 10 over x minus 50x plus 20x plus 405. And by the way, if you did get a function like this, I would say on the sheet, assume c is 0. So you'd get around the x value. So p of x equals 50x minus 10 over x plus 50 over x minus 20x minus 405. That's my profit function. What's next? It says find the number of units demanded that would maximize profit as usual. So I have to find the first derivative. And I have not simplified this yet, sorry. So P of X is going to be equal to 30X plus 40 over X minus 405. Now that's my profit function, simplified. I'll take the first derivative. First, I'll write this like this to make it easier for me. Plus 40x to the minus 1 minus 405. So this is going to be P prime. It's going to be 30. Now this is going to be minus 40 x to the minus 1 minus 1. Well, when you take the derivative, you subtract 1. When you do the integral, you add 1. This is minus 0. So P prime x is 30 minus 40 x to the minus 2. Or you can write it as 30 minus 40 over x squared. Now you want to find the value of x that's going to maximize profit. I'm going to set this equal to 0. 30 minus 40 over x squared equals 0. And we'll go back up here. 30 equals 40 over x squared, cross multiply. 30x squared equals 40. X squared equals 40 over 30. 4/3. Take the square root of, and you got to get x is going to be the square root of 4/3. So the square root of 4/3 is 1.15. So this could be a very large product, maybe an airplane or something. Because how do you make 0.15 or an airplane? Well, you make a small plane. You take 15% of a big, large 737, and you build it to that specs. That's how we get the Cessnas and the Beechcrafts.
And perhaps a drone if it gets small enough.
And perhaps a drone if it gets smaller. Now, is this at a max or a min? That's what you have to know. In this case, P prime x, which I didn't put on there. Well, what was my P prime x? Here we go. It's somewhere here. 30 minus 40 over x squared. Let's say x to the minus 2. I'm going to use the second derivative, which is 0 plus 80 x to the minus 3 plus 80 over x to the third. That's my second derivative. If I put in minus 2 times that, came out to be a plus 80 over 1.15 third. It's going to be a plus. Let's make sure we did everything right here. 30 minus 4 over x squared, x to the minus 2. The derivative of 30 is 0. The derivative of this is minus 2 times 40 is 40. Minus 2 minus 1 is to the minus 3. Notice this is greater than 0. What's wrong with that? Greater than 0 is a minimum. So I have not found a critical point which maximizes profit. This minimizes profit. And you will get, especially on the finals in QBUS110, you will get weird things like this. You will get where they ask for maximum profit and you come out with a minimum. We get a cost function and they ask for minimum cost and they come up with a maximum. Just report what you find. That's it. All right, so it says here, find the number of units of product demanded sold to maximize profit. Well, in this case, we can't. The only way we could is to draw the function. What they'll usually say in a problem like this, which I've said on the, is to draw the function, graph it, and look at the maximum value. And that's usually going to be within certain values, maybe where x might be, this confined between 0 and 20. And usually in cases like this, 20 would be your maximum value. All right, so if you don't get it, just report what you get. I believe there's one on the final that does this. It throws a curve at you. Okay, let's do another one. I'm going through the review sheet. And let's do, now notice if you look at page 5 and 6, we have 3 problems labeled 15. Okay, so some gremlins got in there. I'm going to call the first one 15A. That's the one that says y equals fx minus 3x squared minus 2x minus 1 divided by 4 minus x. That's 15A. 15B is going to be Rx equals 2000x squared, the log of that function. And 15C is going to say sketch the graph of the irrational function. So let's do 15C first. So what do I have here? I have the function equals x squared divided by x minus 2 squared. Well, the first thing I want you to find is the domain. Well, we're not interested in the domain in any of my tests. That was last year. But now we're going to find the asymptotes. So let's say find all asymptotes. All right, well, to find your vertical asymptotes, you set the denominator equal to 0. Okay. Well, if I take the square root of both sides, square root of 0 is 0, so x equals 2. So 2 minus 2 would put a 0 into the denominator, give you an asymptote. This is your vertical asymptote. Horizontal. In this case, you have to revise the problem. You have to do what it tells you here. You're going to FOIL this. X squared minus 4x plus 4. This is n. This is m. The rule says if the power of the numerator of the first term and the power of the first term denominator, if they're equal, then the horizontal value is simply the coefficients in front of the x squared terms, 1 over 1, so that's 1. So your horizontal, your vertical asymptote is 2, your horizontal asymptote is 1. If you don't believe it, draw it. Part 2 says find all x values that are critical values. Well, in order to do that, you have to differentiate. So now we have the horizontal asymptote is 1, vertical asymptote is 2. Answer to A. We want to find critical values. Okay, take the derivative. This is a quotient rule. This is U over V. So the quotient rule is dy dx, v du dx minus u dv dx over v squared. I have to warn you, some of you people are still doing this by taking u dv dx minus v du dx. That's not going to give you the right answer. This is the rule. Take the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Don't make up your own rules. So df dx here is going to be the bottom times the derivative of the top minus bracket the top times the derivative of the bottom over the bottom squared. So we get here x minus 2 squared times 2x minus x squared. Now this is a chain rule. A is 1, n is 2. 2 times 1. The derivative of this is 1. This is going to be a real easy one. This is going to be 2 2 times x minus 2, 2 minus 1, times 1, over x minus 2 squared. Don't forget the division. All right, let's go and continue with this. So df dx equals x minus 2 squared times 2x. I'll try to write bigger. X minus 2 squared times 2x minus, I have 2 times x, it's 1, it's x squared, it'll be 2x squared, x minus 2 to the 1, divided by x minus 2 squared. All right, now I can factor x minus 2 in the numerator. Okay, so this is going to be x minus 2. X minus 2 times 2x minus 2x squared divided by x minus 2 squared. I'm going to simplify this as much as possible. So first of all, I'll simplify what's in there. X minus 2 is on the outside looking in here. It's going to be 2x squared minus 4x minus 2x squared. That's convenient. These cancel. Now let me divide the top and the bottom by x minus 2 to the 1. That cancels. And this becomes minus 4x over x minus 2. And that's your first derivative of x. Very simple. Let's see what they want you to find next. Critical points, max, min. Okay. I'm going to set this equal to 0. Now, what's the problem here? Really no problem. I'm going to multiply the top both sides by x minus 2. That means minus 4x equals 0. So x equals 0 again. So that could be a max or a min, depending upon where we are. And we might have a problem with the minus 1 and the plus 1 again. But since this problem also asks you to find inflection points, instead of using the first derivative sign test, I am forced to take the second derivative anyway. We'll use the second derivative to test max or min. So let's put up here that from the first derivative, the critical point was x equals 0. So it wants me to find inflection points. In order to find inflection points, I have to find the second derivative. So let's say the second derivative is a derivative of the first derivative. First derivative, and after we reduced it, was very simple. Once again, this is quotient rule. So f prime x equals the bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. So here we get 4 minus 4x, the derivative of this is 1 over x minus 2 squared. This is going to be 4x minus 8 minus 4x over x minus 2 squared. We don't need to factor here. 4x minus 8. This is going to be minus 8 over x minus 2 squared. Let's see if we did everything right. First times the derivative of the top, 4. Top times the derivative of the bottom, which is 1. This is my second derivative. So let's test now x equals 0. So I'm going to use my second derivative, test to see if x equals 0 at max f of x. Well, f double prime is 0. What do you want to do? Then minus 8 over 0 minus 2 squared. It's going to be minus 8 over 4. Minus 4 is less than 0. And yes, we're at a max when x equals 0. Anybody with me so far? Have any problems? All right, I'm not going to use this to do diminishing returns. I have another one which is more like the one that I did in the exam. I just wanted to get down to the second derivative. This one has no, if we set the second derivative equal to 0, we get no inflection points, nothing like that. So therefore, I'm going to do one which has inflection points. So I'm going to stop here. And I just showed you how to use the second derivative to determine, now x equals 0 is at max f. I don't know what f is, so it could be. It could be that the more we produce, the more we lose. That's a company that's not going to stay in business long. As I said, these are from old final exams. One thing about the old final exams in QBUS110 is the numbers were horrible. I made sure in my exams that the numbers work out very, very well. Okay, let's do now. Just let me skip a little bit. Number 30. Number 30 is just like a problem on the exam. A company sells X. I'm on page 10. X number of units of product as a cost function. $80 minus 34 e raised to the 2x. The price function is given as 400 plus 2 log x minus 6. What would the revenue function be? And that's what they ask you. Find the revenue function. Revenue equals px. Well, it's 400 plus 2 log x minus 6 times x. There's going to be an x in front of here. 2x log of x minus 6. There's your cost function. There's your revenue function. Find the revenue function when x equals 10. 400 times 10 plus 2 times 10 log 10 minus 6. That's the natural log. I'm not going to do it out for you. Just multiply and find the natural log on your calculator. Part C. Find the marginal revenue when x equals 8. So I want to find the revenue that's going to be the derivative of 400x plus 2x log of x. Now, what's the problem with this? Let's see. Notice we haven't used the cost function yet. All right, let's put the cost function over here. Let's put the cost function over here. 80 minus 34 e to the 2x. Okay. The derivative of r with respect to x is the derivative with respect to x of 400x plus the derivative with respect to x of 2x natural log of x minus 6. First one's no problem, right? It's going to be 400. Everybody see that this is a product rule? This is U and this is V. So it's going to be UV plus UdV plus VdU. 2x, derivative with respect to x of log x minus 6 plus log x minus 6, the derivative with respect to x of 2x. All right, the derivative of log of x minus 6. If y equals a log of u, the derivative of the rule is a over u du dx. So in this case, this is going to be u is going to be equal to x minus 6. A equals 1. And du dx equals 1. So in this case, we're going to get plus 2x. And the derivative is going to be 1 over x minus 6 times 1. Okay? And this is the log of x minus 6 times 2. Same log rule we used before. This is 400 plus 2x over x minus 6 plus 2, the log of x minus 6. And that is r prime of x. Okay, now the problem doesn't ask you to go any further. I am going to find the derivative of cx, and that's all I'm going to do with this problem. There was a problem on our test, number 2, which had you subtract them. So there's your derivative. It's a function of x and log of x. Well, let's look at our cost function, which is right up here. I didn't have to do it. And let's look at the derivative of our cost function. Which is the derivative of 80 minus the derivative of 34e to the 2x. All right, the derivative of c prime x is 0. What's the exponential rule? Exponential rule says if I have y equals a e to the u I don't know why I keep dropping this. Okay, if I have y equals a to the u, it says dy du, dy dx is a e to the u du dx. So in this case, u equals 2x, du dx equals 2, and a equals 34. Working right on here. So it's going to say that dy dx is going to equal 34 e to the 2x times 2. 68 e to the 2x. And that is my derivative because this is 0. So this is actually the derivative of c prime x. Now somebody had a question, why do we need a constant? We only need a constant when we integrate. This is completely a differentiation derivative problem. That's all I'm going to do for this one. Just wanted to show you log and exponential differentiation. And we do have to go and do some more integration. And let me see if I can find another one that I didn't cover yet. We did present value. We did demand. We did Gini coefficients. We did marginal cost. And we didn't do a straight line. Okay, let's do a straight line. There's a straight line problem on the exam. There always is. Find the line tangent to the curve at a particular point. So let's see what we have here. I'm on number 15A, which is the bottom of page 5. Okay. Now, since we have already done one of those, well, let's just do it. Okay. 15A, I'm given y equals 3x squared minus 2x minus 1. Divided by 4 minus x. You know, I'm not picking it up again. Thank you. Question? Or somebody's entering or okay, this is a straight line problem. A, find the slope of the function. Find the slope of the line tangent. We can call this f of x at the point x equals 1. Now remember, the slope is a derivative. And it's a derivative at the point x equals 1. So we have to find the derivative, which once again is a quotient rule. So dy dx is going to be 4 minus x, the bottom, times the derivative of the top. Minus the top. Times the derivative of the bottom divided by the bottom squared. Now I don't even have to simplify this. I just have to take the derivative. Derivative of 3x is going to be 6x minus 2 minus 3x squared minus 2x minus 1 times minus 1 over 4 minus x squared. Now I don't have to simplify this. I'm just looking for dy dx when x equals 1. Just put 1 where you see x. All right, so just without simply, you have a little more calculation, but it's really not much because it's 1. It's 4 minus 1 is 3. 6 minus 2 is 4. That's 12. 3 1 squared is 3. Minus 2 times 1. 2 minus 3. 3 minus 3 is 0. Over 3 squared. 12 over 9. Or 4/3. That's your slope. That's your A. That's your slope. What's your next step here? It says find the y value at x equal 1. In that case, I have to go back to the original problem and find the y value. This was A. B. Find y when x equals 1. Let's go back to the original, which y equals 3x squared minus 2x minus 1 over 4 minus x. Okay. I'll just put in 1. All right, that's 3 minus 3. 3 is going to be minus 1. This is going to be 3 minus 3 minus 1 over 3. And what's that going to be? That's going to be minus 1/3.
3 minus 2 minus 1. Numerator. 1 times 2.
Oh, it's just 2. I'm sorry. 2. So that's going to be 1. It's going to be 0.
It's like 0 to me.
Yep. Times 1 is going to be 0. All right. What's our formula? Y minus y0 is A, x minus x0. Oh, was this 0 before? It was a derivative, right? I don't remember if that was right. Well, let's. What was the derivative? Derivative was. Got a question? No? All right, so we'll go with this. This is 0. Yes?
That might be an alarm saying that we're like within 10 or 15 minutes of the 2-hour mark.
Okay, so y is 0 equals A, which is 4/3. No, that's right. X minus 1. So y is going to be 4/3 x minus 4/3. And there's your equation of your line. How much time do we have left?
Well, it's 5 after 3, and we started about 10 after. So
A quarter after, right?
I think we actually started with the teleconferencing and everything, maybe somewhere around 10 after. So the computer, if it is timing for 2 hours, it might cut off at 10 after.
Okay. All right, I just want to do if I have time, a diminishing returns problem with an inflection point, and it's going to be number 33, which is px equals minus x third over 3 plus 2x squared plus 2x. All right, let's find inflection points. That means I have to find the second derivative. First derivative is going to be 3 times going to be minus x squared plus 4x plus 2. The second derivative is going to be minus 2x plus 4. Now to find inflection points, possible in inflection points, you set the second derivative equals 0. So minus 2x plus 4 equals 0. Minus 2x equals minus 4. X equals 2. Now we don't know if that's an inflection point. That's a possible inflection point. So we have to test using the second derivative sign test. Draw my line. Test the 2, 1, and 3. So I'm going to use my second derivative. And I'm going to do p prime of 1 equals minus 2 times 1 plus 4. That's plus 2. That's greater than 0. P prime of 3 equals minus 2 times 3 plus 4. Minus 6 plus 4 minus 2 is less than 0. So this tells me that my p double prime of 1 is greater than 0. This tells me that my p double prime of 3 is greater than 0. Greater than 0 is at a min. It would be like this. That's going to be concave up. Greater than 0. Less than 0, sorry, is at a max, like this, concave down. Is this a point of diminishing returns? Well, it is an inflection point. So what's our decision here? Our decision here is because there's a change in concavity, x equals 2 is an inflection point. X equal 2 is also a point of diminishing returns. And the reason is, you go from a smile to a frown. You're happy until your returns start to, so you go from a smile to a frown, you get your point of diminishing returns. I'm sad when I start to get less money. Okay. How are we doing?
I mean, everything still seems to be running. It's 10 after 3.
So what do we have?
It's completely up to you. There's, well, looks like
Are there any other questions in the review sheet that are going to be in the exam?
All the guys, one at a time.
I think there's a little bit of feedback. She said, are there any other questions on the review sheet that are going to be on the exam?
I would go over, and if you have problems, I would go over page 8, because there are some just plain old derivatives and stuff like that. I would go over page 8, 22D. For integration, I go over 23C, that's the chain rule, and 23A, that's the chain rule. And if you flip back, I believe, to page 7, might not be, it might be page 9. Page 9, 25, you should be able to do A and B. So I do have some just isolated derivative and some isolated integration problems. What they usually do on these finals is put more integration, but since we spend a lot of less time there, I made the final more comprehensive. There are a number of parts. I don't think there is anything that I didn't cover. And as I said before, the big numbers and the numbers that don't turn out right from the old sheet, don't worry about it. All my numbers come out right. I have a Gini coefficient. I have a present value. I have one with marginal cost, marginal revenue, the way I did before, having to integrate and find the constants. I have one with a straight line, find the slope, find the other value of y, and use the equation. I have one with a rational function, asking for asymptotes, derivative, and the critical values. And then I have the derivatives and the integrals. I think I've covered pretty much everything, every topic that will be on the final. If you know how to do the basics of what I did, you should be all right. Now, some of those problems, like the Gini coefficient that didn't come out because of an x value, don't worry about that. Yours will come out. The time I do this for review sheet, I'm going to get rid of those. You're going to have 3 hours. And if you need more, don't worry, I'll give you more. I just want you to finish it and finish it well. If you are in a situation where you can't do 3 hours, where you can only do 2, or you can't do more and you need more time, please tell me before you take the exam that you will not be able to go 3 hours. We'll figure out something for you. Everybody's gotten the extensions on the worksheet, the extensions on the homework. People have asked for extensions. I'm extending everybody pretty much till Friday at 10 p.m. I know you guys are up against a lot of other courses. I have to get my grades in Monday. So Friday at 10 p.m. is really the latest time to get everything in. Otherwise, I'm going to be up against the grading deadline. If you have questions, please contact me on Hangout or contact me by email. I try to answer every question that you ask of me. And I'm going to have office hours right after this ends. Then I have office hours all day tomorrow. And on Thursday, email me and tell me if you want to do something before the exam. Everybody knows when the finals are. I've requested to take the final at a different time, not Thursday, Friday. Pretty much, if you want to switch right now, there's no constraints. If you have a conflict on Thursday, we have to take an exam at 6 and you won't get the 3 hours, then take the exam Friday. If you have a conflict Friday, take the exam Thursday. Any questions? Did it cut out?
I don't think so. You guys,
Okay.
you guys still there? Can someone say hello?
Somebody say hello? Probably cut out.
Yeah. It shows there's still a few on.
Oh. Anybody have any particular questions? Anybody have any particular questions on anything? I would say at this point, we are going to be cut off. I would say ask that question by email. Okay? I think at this point, we'll just end the session, unless there are any more questions. I have covered almost every topic that's going to be, practically every topic that's going to be on the exam.
Okay.
I'll either see you on Hangout or I'll talk to you when we have the exam. You will get instructions, final instructions on how to get the final and what to do starting Thursday.
Okay.
I think we're finished.
Good luck, everybody.
Yeah, good luck, guys.